Hello, discrete math fans. We're now going to discuss R combinations with repetition allowed. Now in the last section, we showed that there are n choose R combinations, or subsets of size R, of a set of n elements. Another way of describing this is we can say that there are n choose R ways to choose R distinct elements without regard to order from a set of n elements. So it's the order that distinguishes combinations from permutations. With a permutation, order matters. With a combination, order does not matter. For instance, we can say that there are 5 choose 3, which is 5 factorial over 3 factorial 2 factorial. That's 10. 10 ways to choose 3 elements out of a set of 5. Here they are. These are all the 3-element subsets of a set of 5 elements. Notice that order doesn't matter. We have written the set 1, 2, 3. We have not also written down 3, 2, 1 because that's the same set. We're now in a position to ask a related question. How many ways are there to choose R elements without regard to order from a set of n elements? But now here's the change: if repetition is allowed. For example, let's suppose, like in the previous problem, the items that we're picking can be chosen to come from the set 1, 2, 3, 4, 5. If we can choose 3 elements, then maybe we could choose 2 3s and 1 5, or maybe just 3 2s, or perhaps we could choose 1 2, 1 4, and 1 5. You see, now we're allowed to repeat elements. And here's the notation we're going to use. We'll use square brackets to indicate one of these items. Where, for instance, if we choose 2 3s and 1 5, then we'll write bracket 3 3 5. All 2s, then we go bracket 2 2 2. The one at the end, the 2 4 5, it's an ordinary set, but we're going to use the bracket notation because we're thinking about that we're allowed to pick more than one element. Order doesn't matter still, so we're going to say 3 3 5 in the brackets is the same thing as 3 5 3 in the brackets. All right, here's the definition that we want to make. An R combination with repetition allowed, or, this is another term that we might run into, a multiset of size R, is chosen from a set X of n elements. What it is an unordered selection of elements taken from X with repetition allowed. So if X is the set containing x1, x2, all the way up to xn, we're going to write an R combination with repetition allowed, or a multiset of size R, as x sub ji, x sub j2, all the way up to x sub jr, that's enclosed in brackets, where each x sub j is an element of big X, and some of the xjk's may equal each other. With sets, they're not allowed to equal each other. With multisets, they are allowed to equal each other. Okay, that's all for now.